Alright, hello my friends. Today is Monday Science, and today we are doing, we're still in that module 2, learning about electrical and magnetic forces. We're in lesson 2, which is all about magnets and magnetism. Oh, my mic doesn't want to work for me. But this is day 4. We're really close to wrapping up our learning about magnetism. And so we're going to watch a video today. And we're also going to do another really mini experiment, but before we do, we're going to answer some questions, because you guys did lots of reading last week. Is my mic working? Aha, here we go. You did lots of reading last week, and so let's start with this video. Check it out.
Check it out, check it out, check it out.
Have you ever used magnets?
Yeah.
What did you notice? When you put two magnets close to each other, they may attract or pull closer to each other. They may also repel or push away from each other. Magnets can attract or repel each other without even touching. The force that causes this to happen is called magnetic force. A magnet is any object with a magnetic force. Magnets can also attract things that are made of certain metals like iron. Magnets can even attract or repel objects through solids, liquids, and gases.
I've done that before.
Magnets cannot attract things made of wood, glass, plastic, or rubber. There are many uses for magnets. Magnets are what make a compass work. The red pointer in a compass is a very lightweight magnet. Earth has a magnetic field. It behaves like there is a giant magnet with one end near the North Pole and one end near the South Pole. The red pointer of the compass will always point toward the north because the magnet is attracted to that part of Earth's magnetic field. Did you know that magnets are used to make roller coasters start and stop?
Yep.
Yeah.
Magnets are also used to keep refrigerator doors shut. They're used in speakers,
I did.
TV screens, computer monitors, and telephones. Magnets help display beautiful works of art on your refrigerator. What kinds of things will you use today that are made with magnets?
Sounds like a worm. Slinky. Slinky.
So that video was a really great reminder of some things we've already learned about magnets, but also there is some new stuff in there. Who would like to share something new that you just learned in that video? Or maybe something you already knew, but something new that we've talked about as a class. Braylon. Good. Magnets can attract or repel. That was a good review thing in there. Olivia?
Stick a magnet on the table and put another under it.
So magnetic force can travel through objects. That's something we're actually going to explore today. The one for me that I always seem to forget is that magnets control roller coasters. How many of you is that new for? I hear it every year with this, and I've seen it. There's like mega magnets on the roller coasters at the start and finish, but I always forget because it seems like that's something that should be way too big to be powered by magnets, but it tells you the magnets be pretty powerful.
Yeah.
Yeah. Was there anything new for anybody else? Acid?
Compass works. Compass works from the Earth, and the Earth is like magnetic.
Absolutely. The Earth has magnetic poles, and those are what compasses are controlled by. Is compasses are made of a very light magnet that turns toward north always. Riley?
I have a question about the roller coaster magnet.
Sure.
What part has the magnets on?
Oh, here, let me show you guys a picture of that, because that was something I was interested in. Magnets on roller coasters. So, combine strong magnets with a roller coaster, and one develops an efficient way to launch a car forward quickly. Have any of you guys used Hot Wheels in the past?
No.
Okay, and like Hot Wheels usually have like a gear that's spinning and kind of launches it. These run by
Yes, I
magnets.
have
So
that.
all these metal things right here, they're magnets. So these are probably the ones
I
for
have the crazy 8-track.
these ones here. When it's getting to the end and the roller coaster has all of that momentum from coming downhill or whatever it was doing, these are the ones that would slow it to a stop at the end. So there's a little magnetic bar in the center of the bottom, and it slides into these, and all these magnets attract the roller coaster to resist it, so that instead of zooming right through it, they're attracting to it and kind of slowing it down. It's
But
almost
how
like
do they-
friction, right? Where those forces are gonna keep pulling it from
But if
continuing
it's
really
so-
fast.
If it's so strong, how does it come off of it?
Because it's moving so quickly. And so a lot of scientists have to do tons of work just to see what speeds work. There is a quick video. Would you like to see it?
Yes.
Someone doesn't care.
Whoa.
Magnetic brake demonstration is said. So here's a roller coaster, and when it gets to the end, all of a sudden you're gonna notice kind of like a slow down.
Oh, that looks fun.
So there's not magnets happening on the main part of the track. When it's going up and down hills and stuff, that's just from the momentum from gravity.
And what we have here, these are magnets. Ridiculously strong. You have to be very careful. This is how strong they are.
Oh, it's going through his hand.
Right through your hand. See that?
Wow.
Now what we're gonna do, backside of the magnet is the steel. This is the actual magnetic part. That's the magnet. That's the steel. So first demonstration is steel to the old. This one also. Now we use the magnetic side.
So it's constantly making it go at what speed? Is it getting faster or slower?
Slower.
It was much slower.
It's not even working.
Watch how strong these magnets are. Watch this.
Oh,
Try to get them apart. So you see. If you ever need a really strong magnet, rip apart an old hard drive because that's where you're going to find what's considered rare earth magnets.
crazy beans. So we're gonna go ahead and continue, my friends. In your science workbooks, I need you to flip to page 75. What page? So let me shift my camera also.
How
My
come
camera-
every day? How come every day is like an experiment?
Most of this we're going to talk about instead of writing. So you don't need your pencils yet, but you will need to be ready to share. So we already read all of those pages. In fact, you didn't just read 259 and 260. You read the whole section on magnets. So we're ready to use words like magnet, magnetism, magnetic field, and pole because you read all about those vocabulary words. Stacks. We're not playing with gloves. Those may go in your coat pocket until recess time if you go outside.
We're not
Or
gonna
they're
go
safe
outside.
after school. In your coat pocket.
We're not gonna go outside.
So I'm curious. Hocus pocus.
Everybody focus.
This is page 75. What page is it?
75.
What is magnetism? Who can tell me what is magnetism? Abby, what page is it? What's magnetism? Hendrix. Ooh, when things attract by what type of force? Good. Addison, sit up. Third graders, sit up, because if we're not participating and we're not all listening and talking, then we're going to have to write them.
We're not all.
Otherwise, we got to be ready to share. Hadley, we are on page 75. Can you tell me what page we are on? Well, it's in between 74 and 76. Magnetism. It is the magnetism, just like Hendrik said, things attract, but magnetism specifically is the ability for magnetic force to attract or repel things. So magnetism is when things have the capability to use magnetic force to move objects, which means that they're probably made out of what material?
What's a hard
Who remembers? Maddie.
metal?
Metals. Certain types of metal, right? Gunnar asked what a hard drive was from the video. Hard drives are the inside of your computer. So are we going to be going around breaking random computers apart?
Yeah.
Absolutely not. Maybe if your parents had a really, really old computer that they're ready to get rid of, that could be a time. But typically that's not something we would do. Numero dos.
Can we break your computer?
Oh, wowza.
No.
Numero dos.
Numero dos.
Draw how two bar magnets can attract and repel each other and use north and south to label the poles. So, here's what I should see. I want to see 3 different pictures. How many?
3 different pictures.
This one you actually need to draw. So to draw bar magnets, you're going to draw rectangles. Okay? And you're going to draw them side by side. There's example 1. Example 2, and example 3.
Are we writing this?
Yes, you are. Now, if these are bar magnets, what are we going to have on each side?
North and south.
North and south. So you need to choose. I would like you to have this first one attracting, which means you're going to show arrows where they're coming together, and think about what symbols would go here. The second one I want repelling. They're going away from each other. So think about the symbols that would be facing each other there. And then a second example of repelling. So the top one is the poles that would be touching to attract. And the bottom 2 are going to be 2 examples of how your poles would be to repel. Online friends, I will put this on your slides. My friends in here, you are drawing this in your workbooks.
Already done.
Yep, it doesn't take too long.
What is the last one?
What'd you put for the middle one?
And M.
Okay, so what would be another one that would repel?
SS.
Quick check, who can tell me which 2 poles would attract? Olivia.
North and south.
North and south would certainly attract because they are opposites.
Or south and
Who can give me an example of poles that would repel? Braylon. North and north are like, so they would repel.
That's
What else would repel? Savannah.
South and south.
South and south. SS for Savannah. Or for Stacy Scholes. And we're going to turn the page.
Turn the page. Turn the page. Turn the page.
Because we want to get to this experiment, so we need to be ready to chat. Numero tres.
Numero tres.
Did any of the information from that video confirm or prove your findings or observations in the Investigate with Magnets activity? So when you guys were going around the room or going around your house and using magnets and figuring out, hey, what has magnetism, what doesn't? When we did our experiment to test objects like our paper clip or change or pencils or a crayon, how did that video confirm or prove or further make you understand something from our magnetism activities? Who can tell me something that happened in the video that you were like, oh, that's just another example of this? Maddie. So when they show, you could have 2 magnets maybe that connect through a table. Did you do that when you were exploring the room before? Oh, well then that's not anything that's confirming your regular findings. Who noticed something when they were walking around the room with the magnet or something from our experiment that video proved the same thing? Brielle.
Can it be on both of the videos?
Yeah? So that we have a steel frame around our door for my online friends that can't see it.
They both stuck to each other.
What's stuck to each other?
The black steel stuff and the magnet.
Good. So the magnet stuck to the steel frame around the door. Yes. That was proved. They showed steel in our video, right? With the guy that was explaining the braking system for the roller coasters. Steel was the big sheet that they dropped the brake magnet down and it slowed down that brake. Are you guys ready for another experiment? Daxman, since you are over there, one of those top drawers has rulers. Would you grab me a ruler, please?
Oh, we're gonna measure how far.
And I'm curious, my friends, this inquiry or experiment that we're going to do has a ruler and 2 bar magnets, and we are going to measure the distance between magnets and observe the attraction. So what you're predicting is if blank, then blank, because. So you're going to choose if you pull the magnets further apart or if you put the magnets closer together, and then go ahead and follow up with that. Which one would we rather do? Further apart or closer together? Okay, so our hypothesis is if we, and you guys are going to finish this, but I'll get you started. If we pull the magnets further apart, then what do you think is going to happen? And then why? Then this is going to happen because blank. Thank you, sir. I'm going to give you a couple seconds to jot that down.